अब तू है ना, मैं इधर बोल बोल मत कर, रिकॉर्डिंग में चल रहा है सेशन, अब तू इधर मत, अभी तेजी मत करवा। तो
सही से बोल जरा,
मैं ऐसी तेजी में हुआ, अब तू चुपचाप है अपना, ये इधर रिकॉर्डिंग चल रहा है सेशन, अब रिकॉर्डिंग होगा सेशन मेरा।
तौलिया का अंदर ये है तौलिया के अपन खटिए पर रखा दो। खटिए पर रेडी बनी है, इसको लेके रखा है।
हेलो ओ भाई, कोई आया भाई?
हाँ नमाज हो गई। काम से देख हाँ हाँ जी रात में खीर बनाई, मैं खीर बनाई अभी नहीं नहीं है, मंगवा दूंगी इनसे। और पापा और मां चावल बिल्कुल नहीं खाते, तो कहीं उस टाइम दाल चावल बना के दी थी, दाल चावल बैच वाला है छोटा वाला हाँ छोटा वाला ये ना हाँ ये नहा लिए
हाँ
खाना खा लोगे
कपड़ों में पहने
हाँ
कपड़ों में पहने
सब खोज के दे ली तौलिए जे हम बजे के बाद
आपको बात नहीं है ये तो कपड़ा पहन लीजिए मौका मिलता है नहीं थोड़ा बाजार जाना पड़ता है वैसे आका आका ही रह जाता है
वाजे भी ले आना है 140 रुपए लगेगा
काफी लिया है ना कल खाती बोलते नहीं क्या करते
और ये वाले 5 किलो मांग ले आना
अरे नया तो कन्या में हर सामानवा के ना है क्या तू कुछ सामानवा के है रेट महंगा अब कोई कोई सामानवा सही मिल जाए
5 किलो वाले 5 किलो मांगा
किलो मक्का 5 किलो बाजरी बाजे
हां जी
तो आया होता ना हाँ जो पैसे में लाएंगे है ये मक्का बाजरी गेहूं में मिला के लेकिन एक बनाने में मजा आ जाएगा अच्छा तरह से करें है ना ठीक है लेके आती है वो लेके आती है अपनी निकाल कर बहुत चोर को कौन ले देखा तू अरे हम नहाए धुलने का हम उतना ध्यान दे लेकिन रेखा जब ऐसे रहा ना वो तुम्हारे जैसा तो ना एकदम मुड़ ढीलने लगा कि आप पैर वगैरह तो सही लगा लाइन तो फ्री है अब जब तो मालूम पड़ गया हम सर कर गया हम लोग थे अच्छा ठीक है ना बोलो ये जरा अपने लिए सही रहता है ओके मजा आ जाता है
This conference will now be recorded. Yeah, good morning to everyone. So the last session we started with blocking and non-blocking, right? Can you differentiate what is a blocking assignment and non-blocking assignment in the procedural blocks? What are the two types of procedural blocks we have in the very last? Initial block and the always block. How initial block scheduled or executed? One time in the simulation, where always block will be executed. The content like look like passion, correct? So, what is the use of the initial block? Initial block is most of the time it is recommended to use in the test benches for displaying, monitoring, waveform initialization. Correct. This is not synthesizable. This is not recommended to use in the where test. It is not recommended to use in the design file. Initial block. Initial block can be used in the test bench. Not used and not recommended to the what file? Design file. So always blocks are recommended to use in design file to modeling the what? Behavioral style of modeling can be done through the always block. So the statement inside these procedural blocks are sequential statements. So those sequential statements are further differentiated into two types. One is blocking and the non-blocking. What is meant by blocking? How they are scheduled to execute in the blocking? Step by step, right? Line by line execution like other languages C, C++. There is sequential execution of the statements. Non-blocking execute like concurrently, parallelly. What are the two processes are involved in the non-blocking? Read and write. Read operation and the write operation. So how this will be doing the read operation, write operation? All the statements here concurrently started executing. The right hand side expressions will be evaluated. That will be read into the what? Where it will be read into the temporary variables in the simulator. At the end of the timestamp, that will be right into the what? LHS, right hand side, left hand side variables. So these are the block, the non-blocking method can be working. Did you understand? So there is one problem we saw that when you are trying to swapping the two numbers, blocking assignment will not do proper. It produces the what problem? Trace problem. Basically, swapping is not happening. So the same thing you can do using what? Non-blocking operation. So today let us begin with few more examples of blocking and non-blocking. What is a good practice where you can use the blocking statements, where you can use the non-blocking statements? I said that most of the time blocking will be recommended to modeling what? Combinational logic circuit. And then non-blocking can be recommended to use for the sequential. Now let us take a few more examples today and we'll see how you can use the blocking and the non-blocking. This is what we talked about in the last session, blocking and the non-blocking. Now let us look at some example of using blocking and the non-blocking assignment. What is the main objective is that to get a feel that type of assignment statement to use for some particular scenario. Okay, so avoid some of the not so good design practices in the modeling. So we'll concentrate on these three motto today. Okay, let us take one example for the blocking and non-blocking. So this is a code for multiplexer. What multiplexer is nothing but 8x1 mux. Correct. 8x1 mux. How you can model this in the assign statement using data flow modeling? The 8x1 multiplexer will be having how many inputs? 8 inputs, 1 output, correct. I0 to what? I7. And then how many select lines will be there? 3 select lines will be there. S2, S1 and S0. 1 output will be there. How you are modeling this using a continuous assignment statement? Using assign keyword, right? Assign. So y is equal to what? If you write a Boolean expression, that should be very big Boolean expression, right? S1 bar, S2 bar, S1 bar, S0 bar into I naught, or you can model like this, right? Model like this based upon the select line. So it is going to select I naught, I1, I2, I3. So this is a way you can model this using what? Continuous, right? Assignment statement. This is continuous assignment statement. Suppose how to model this using the behavioral style? Behavioral style. How to model this using behavioral style? So using some of the control structures like I'm using the case here. Okay, this is the module name, input and output port. Module name. Order this is nothing but port list, input, select line, output. Then what are the inputs are? So 8x1 multiplexer, how many inputs will be there? 7 down to 0, vector, and then this is 2 down to 0 means what? Select line. So output declared as a reg data. You know that why it is declaring as a reg. When you are modeling what model of behavior it is? Behavioral description model. Correct. So now always at the rate we are writing what? This is an event where select line S2 changes, S1 changes or S0 changes, your always block will be responding to that triggering event. Correct. So I'm using case statement here. Case select line. It is 3 tick B00 means what output it is going to select? IN0. 001, IN1. 010, IN2, IN3, IN4, IN5, 6, 7. When it is a default, what it is going to select? 1 tick BX. What is 1 tick BX means? Unknown state. If my select line is other than 000 to 111, if I am giving XXX, which case it is going to execute? It is going to execute in the default case. If my select line is 000, what it is going to select? I0. 001, I1. 010, 2, 3, 4, 5, 6, 7. If my select line other than 00 or 111, suppose it is X01, then it is going to select what? Default case. Output is equal to default case. Now, what style of blocking statement we are using here? What assignment statements we are using here? Blocking statement. So this is a combinational logic circuit. So we prefer to use what assignments? Blocking assignments. Did you understand? This is one program for what? For the blocking assignment using combinational logic circuit. Clear. Now let us take next example. So what is this example is? So we are designing the up bar down counter synchronously. So what are the inputs to this? This is a module. Module name is what? Counter. Here mode. What is the use of this mode? Based upon the mode, whether I should go up and then before I start, I should make all my flip flops to what? Zeros. Clear thing. Then what is this? LD means it is going to load the input. To loading the input, we can use load. Then this is D input. How many bit counter we are designing here? 8-bit counter. 0 down to 7 means it is an 8-bit counter. And then clock. And then what? Count. So if I write the model for this is up bar down counter. How I can model this? If I write a block diagram representation of this is nothing but this is a counter, up bar down counter. So how many bit counter we are designing this is? This is 8-bit counter. So D underscore in is 7 down to 0 means this is 8-bit counter. Or you understand? Then what are the output is nothing but? Output of this is nothing but Q. Then we need a clock to this. Correct? Clock. Then what are the other input pins we are using is? One is clear, one is load, and one is mode control. mode control. This is what we are modeling. So when mode is equal to 0, what counter we are doing? Up counter. Let us decide up counter. Mode is equal to 1, down counter. Mode is equal to 1, down counter. What is the use of this load? So here I am representing CLR. This is represented as what? Load. And this is represented as mode itself. This output is Q. Output is Q and input is D. Means if I write like this, what this indicates? Crossline means there are multiple inputs to this. Multiple inputs to this. So what is the use of this clear pin? Before I start, I can make all my flip-flops what? Clear into 0, 0. So I can done this using clear pin. What is the use of this load? You load the input. Suppose I should start from 1, 0, 0, 0 underscore 0, 0, 0, 0. So I can do this, loading this data to the counter. This is upper bar down counter. Upper bar down counter. Using what pin? Load pins. So here mode will decide whether I want to do what? Up counting or down counting. For this we are writing a behavioral model. Now let us go with this. Now this is my module. Module name is counter. So what are the inputs are? Mode is the input. Clear is the input. Load is the input. DIN is the input. Clock. Then there I am writing a output as Q. Here we will taking output as what? Count. Clear. Now we are declaring the inputs. What are the inputs are? Mode is the input, clear is the input, LD is the input and clock is the input. And then this D input means 8-bit counter. What is the vector I should declare? Input is 0 down to 7. D underscore E. Correct? Then what is output is nothing but output reg. So how many bit counter it is? 8-bit counter. 0 down to 7. Count. So these two are what? Inputs. This is nothing but what? Output. This is output. Now we are writing the behavioral model to this synchronous clear. Synchronous clear. So always at the positive edge of the clock. Always at the positive edge of the clock. So using conditional statements. The conditional statement is nothing but if and else statement. If and else statement. If my load, if load is equal to 1, what happens? Count is loading to 1. T. Else, if clear is equal to 1, what we are doing? Count is making what? Clear into zeros. Else, if mode is equal to 1, what we are doing? Up counting. If mode is equal to 1, what we are doing in this case is up counting. If mode is equal to 0, it is going to the else body. What counting we are doing? Down counting. Did you understand? So this how these statements are writing here inside this always block using the non-blocking statements. Are you understand? Blocking you can prefer combination you can prefer the blocking statement. Sequential you can prefer the non-blocking statement. So this will be executed like according to this if condition. If condition is true, if load is equal to 1, what happens? We are loading the D input. If it is 0, where it is going to? Else statement. In the else, if it is clear is equal to 1, now count becomes what? 0. If clear becomes 0, it is going to where? This else mode. If mode is equal to 1, up counting it will do. If mode is equal to 0, down counting. So this is a model of behavioral model for what? Upper bar down counter using 3 inputs facilities like clear, load and the mode operation. Mode will decide that whether I should do the up counting or down counting. So what blocking statements I am using here? What procedural assignment we are using is non-blocking assignments. This is a sequential question. Sequential part, you can prefer the what? Even you can do this using blocking. But as a good designer and good practice to avoid the errors, we should prefer which is a good for the given design criteria. Okay. So with these two examples, we understand that for blocking, sequential non-blocking. For combination, you can go for the blocking statements. Now let us take few more example and we'll understand. Okay. Now look at this one. So this is example for n-bit counter it is. How you can design the n-bit counter? How you can model the n-bit counter? Using parameter, right? So this is a model we are designing behavioral model for the n-bit counter. Model name is counter, and this is what are the inputs? So this is nothing but clear, clock, and the count. So n-bit counter means I am defining parameter. Defining the parameter capital N is equal to what? 7. Then inputs are what? Clear and the clock. Output is nothing but what? Reg 0 down to n. So 0 down to n means what? N value is 7. So this becomes what now? 8-bit counter. How to model this? Always you can write the negative edge or a positive edge of the clock where you want to change the output. Negative edge of the clock. If clear is equal to 1, what we are doing? Count making 0. If clear is equal to 0, we are going to what? Else body. The what is else body is nothing but you are doing the count plus 1. By keeping the different value of this parameter capital N, you can do the n-bit counter. Is it clear? So make it design general for any number of bits using what? Using the keyword parameter. So these parameter values are substituted before the simulation of the synthesis of this model. So that this code can be working for the n-bit counter. You can design a 4-bit counter, you can design 8-bit counter, you can design 5-bit counter, you can design 16-bit counter, any bit up counter it will. You understand? So what blocking statements we are using is non-blocking. The procedural assignment statements we are using is a non-blocking. Did you understand this program? So in this case, what statements we are using? Control statements. If statements. Imagine for the writing the behavioral model, we are not using any logical expressions like in data flow. We are not using the predefined primitive gates to model the counting operation. So the algorithmic level of manner, we are writing a program using the control structures. If my clear is based upon my clear, you do q is equal to 0, or if clear is equal to 0, do clear count is equal to count plus 1. Did you understand this example? Now let us go to the next one. Now you can see using more than one clocks in a module. Using more than one clocks in the module, what blocking statement you can use? What statements you can use here? So I'm using a module. The module name is multiple clock. So I'm taking clock 1 and clock 2, and inputs are A, B, C. Outputs are F1 and F2. Then here I'm declaring inputs are clock 1, clock 2, A, B, C. Outputs range are F1 and F2. Always at the positive edge of the clock 1. But there are 2 clocks I'm using to this. So if you take any complex design, there will be not only the one clock will be there. There will be multiple clocks will be there, any complex design. So I'm taking one example of this multiple clocks here. How you can write the blocking and procedural assignment statement, blocking or non-blocking. So always at the positive edge of the clock 1, whenever the positive edges comes. Whenever the positive edge comes. So what I'm doing here? I'm doing F1 is equal to what? What operation? AND operation. Whenever it is coming to the positive edge of the clock, I'm doing for the clock 1, what operation? AND operation. A and of B operation. So when it comes to what? Negative edge, what I'm doing? This is a clock 1. This is nothing but what? Clock 2. So I'm doing the XR operation. F2 is equal to XR operation. How these two statements are executed? Concurrent, correct? So two always blocks are executing at concurrently, and these statements are start executing at the same time. Is it clear? So that it will do the right operation. At the end of this always block, then that will be assigning to what? Reading into the LHS side. Because I'm using what blocks here? Non-blocking. non-blocking assignment. What assignment is nothing but non-blocking assignment. So this is an example of using the two clocks. Same module using how many clocks? Two clocks. Let us take one more example. So use the multiple edges of the same clock. Same clock with what? Multiple edges. So this is the module. Module name is multiple edge clock. AB, F, AB are the input, F is the output, C clock is the input. And then here output is reg F. And also we are defining the reg T also. Let me define T here. T. Now I'm using same clock, right? Same clock. How many clocks I'm using to this module? How many clocks are there? One clock is there. This is a one clock. This is a one clock. What I'm doing? This is always clock at the positive edge of the clock. This is another always clock. This is at what edge? Negative edge of the clock. Is it clear? First, what I'm doing? First AND operation. T AND operation of B in the next this clock what edge? Pass edge. Did you understand? In the pass edge, I'll be getting this operation. F non-blocking T AND B. Okay. At the same clock, at the negative edge, what I'm doing? First I'm doing at this, right? At T is equal to what? A and of B. So how this will be scheduled? How this will be executed? Concurrently, right? Now whether first negative edge it will happen or positive edge it will happen. Both are concurrently executing. At the negative edge this will happen. What will happen? T is A and R of B operation. Then at the positive edge what will happen? F is equal to T and B operation. If I'm removing this less than, how this will be scheduled? If I'm using the blocking statement here it is equal. How this will be scheduled? If I'm going with the blocking module, blocking assignments. So now simulator dependency here. It may start from this always block. Both are started executing at T is equal to 0. It will be start from here, or it will be start from here, or start from the second always block or first always block. So it will assign the value. After executing of this, then it will start executing this. Is it clear? If I'm talking about blocking module, blocking technique. The non-blocking technique, these two are concurrently executing. Right hand side will be evaluated and read, and then writing it to the left hand side at the end of the timestamp. So here I'm doing in the same clock, at the off cycle only, I'm doing the two operations here. Negative clock, what I'm doing? OR operation. Positive clock, what I'm doing? AND operation. In the off clock, I'm doing how many operations? Two operations. Is it clear? So this is an example of the multiple edges of what? Same clock. The previous one which I showed, we have done it for how many clocks? Two different clocks. Clock 1 and clock 2. Now you can see another example with the same clock. So this is an example of same clock. Module. The module name is multi-edge clock. A, B, C, D, F and the clock. Your inputs are A, B and the clock. Outputs are, let us take this is T. Output is T, comma F. Reg F, comma reg T. Always at the positive edge of the clock, what we are doing? Addition operation. Correct? A plus B. At the negative edge of the clock, what I am doing? C minus T. How this will be executed? This is my clock. Correct? How many clocks are there? Only one clock. Same clock. This is a rising edge. This is a falling edge. This is a rising edge and this is falling edge. At the falling edge, what we are doing? At the negative edge of the clock. So we are doing F is C minus T. At the positive edge of the clock, what we are doing? C is A plus B. A plus B. So here two operations are carried out every clock cycle. Every clock cycle, two operations are carried out. Where C is assigned at the rising edge of the clock. Correct? C is assigned the rising edge of the clock, and F is assigned at what edge? falling edge of the clock. It is assumed that addition or subtraction can be completed in the one half cycle itself. One half cycle itself. The way we are writing the statements here. Addition and subtraction can be done at what? Rising edge addition, falling edge subtraction. Now imagine this is a blocking now. Now it is a blocking statement. How this will be scheduled? It will start executing sequentially, right? Both are start executing at time t is equal to 0. It starts from here or it starts from here. Correct. Either it is a simulator dependency. Which one will start first? Suppose we understand that this is started from here. What happens? Now first this statement will be scheduled and executed. C is equal to A plus B. Now this value will be assigning to what? This. F is equal to what? C minus D. In the case of non-blocking statement, how this will be scheduled? C will be scheduled. This will be taking the initial value, whatever the initial value we are assigning. That will be evaluated. That will be assigning to what? C. And again, this C will take. This is the one which is assigned or older one. The initial value. Initial value only it will take. You don't understand? For the next cycle, it will take what is the value we are assigning. After this rising edge, what is the value it is assigning to C? That value will take at the what? Negative edge. You don't understand? But in the blocking, what happens? New value, what is assigning to C will be using next statements. Correct. So by going with this way, the non-blocking statement